My name is Aayush Rajasekaran. This is John Matthews, and we both work at the Aeon Foundation out of the Toronto office. And today we're going to be talking about how you can build cool stuff quickly with Aeon. Before we get started, just so I know who I'm talking to, of the people here, who self-identifies as a software engineer? Whether that's by training, okay, you write a lot of code, okay, cool. How many people consider themselves to be familiar with the Ethereum ecosystem? Solidity, EVM, okay, good. And finally, how many people have heard of Aion before? Okay, fantastic. In that case, I'll blast through our intro slide. But basically, how we're going to do this today is I'm going to talk for a little bit just to sort of set the stage about what we've been doing and what we're sort of launching and announcing and advertising these days. And then we'll do an extended live demo. John will do an extended live demo in which we essentially want to show off some of our features, but also answer any questions you might have about how you can use our products. And after that, we can have a dialogue, talk about technical stuff if people want to do that. We'll see what people want to do, basically. But yes, the Aeon Foundation, so we're a couple of years old now. We founded with a focus on interoperability, launched our public mainnet just over a year ago. At the time, just had the one Java kernel. In the past year, we've launched a new kernel written in Rust that was developed by engineers in China. And currently, we just have the one virtual machine that we call the fast virtual machine, which is basically a C++-based re-implementation of the EVM optimized for speed, run Solidity contracts. But what we're very excited about, and what we're going to be talking about for the most part today, is the Aion virtual machine, or AVM as we're referring to it. Run AVM, everyone. Which comes out on June 5th on our public network. And the single phrase description of the AVM is that it lets you write smart contracts in Java.
Sorry, I'm just breaking everything here.
It also destroys computers, apparently.
Right. Give it a second.
Oh, I shouldn't.
Okay, there you go.
Well, it's not up yet. Perfect. Definitionally, the AVM is the world's first Turing-complete execution engine that allows you to directly run Java bytecode on the blockchain. There's sort of two important takeaways from that. Number one, the AVM does not touch the JVM. It sits on top of the JVM. It is not a modification of the JVM. It does not re-implement the JVM. And I'm going to hammer this point home a lot because in many ways I think that's might be the AVM's biggest strength, is that it sits on top of a foundation as robust as the JVM. It's one of those we build on top of an existing foundation as opposed to reimagining the entire world. Equally, though, when we describe the AVM as a bytecode transformer because that's what it does, but it's important to stress that it's not translating JVM bytecode into bytecode for a different virtual machine. It's still running on top of the JVM. The actual transformations that it does are basically to restrict the scope of what you can do because the Java world is massive and we still want to maintain properties like determinism, security, and that kind of thing. And also provides a bunch of APIs that basically let you query blockchain-specific things, like the data field and so on. In many ways, the philosophy of the AVM has sort of been to look like the EVM, but doing something a lot cooler, in our opinion, which is letting you write your contracts in Java. We're very excited about the AVM, and that goes without saying. But one of the cool things that's happened lately is that we've essentially been getting external validation from other people that are excited about the AVM as well. So here's an AMA that Sergio Lerner from RSK did last week, a couple of weeks ago. So what is going on?
I don't know. I think the cable's a bit dodgy.
Yeah. In any case, he was asked about essentially what the future roadmap of RSK is going to look like and mentioned Aion and the Aion virtual machine in particular, talked about how it's exciting, how they might want to incorporate that into their pipelines. We've had some conversations today, at this conference with other people who are also interested in perhaps pushing the AVM as part of other projects pipeline, and that's very exciting. If that's something you might be interested in, talk to anyone from the Aeon Foundation. We're all interested in having that conversation. Sort of the claims that we're making, or the thing that I'd like to prove to you and argue for the next little while about the AVM can be broken into 3 points. Number one, lowers the barrier to entry. That's sort of self-evident because the average engineer probably already knows how to code in Java or something like Java. Number two, you get a massive suite of testing and tooling infrastructure. Part of that is stuff that we've developed or we've developed with our partners, but also part of that is just because, again, the Java ecosystem is massive, old, and popular. Also, one of the cool things I think about the AVM is that I'm hoping, and we're all hoping at the foundation, it'll really be an impetus for innovation and focused innovation, by which I mean innovation that's focused on the blockchain space without getting too distracted with everything else in the world. And we'll talk about that a bit more at the end. But yeah, sort of to delve into those points for a bit, I claim that the AVM is very developer friendly. Perhaps the single biggest thing, like I said, is that you now don't have to bother learning a new language because the average person probably doesn't know Solidity or anything like that. So you're using a language you already know, and you don't have to spend a lot of time on that onboarding process. So this means you don't have to download Sol-C. You can just use Java-C to compile and to get your jar ready for deployment. It means if you have complicated dependencies, you can use any of the existing Java dependency management systems. If you want a build process, you can use one of the Java build processes, that kind of thing. Some of these things are things that we'll be seeing in the live demo today. Claim number 2 is that the AVM is robust. The single biggest way we achieve that is by hardening the AVM, by stripping away the things that we don't want to be thinking about, essentially stripping away the non-blockchain related things from the core AVM itself and pushing that downstream to sit on top of the JVM. Basically, we have a lot of faith in the JVM, and I think everyone would agree that that faith is well placed. The JVM is now over 20 years old. Java is the most popularly used programming language in the world, and essentially the world is sitting on top of Java. So if something is wrong there, we'll be one of the few people, we'll fall over, but so will the entire world. And so we're hoping that by focusing on the core blockchain related features and letting everything else sit on top of something robust like the JVM, the AVM will prove to be a lot more robust than if we were sort of worrying about very low level details like what's on the stack and that kind of thing. And finally, I'd argue that the AVM is performant. Part of this comes, again, for free. Any app that's deployed on the AVM is JITted using the Java JIT compiler. Also, the JIT compiler, as people probably know, is going to run over and over again on your code every time you execute it. And so it's basically going to get better with time. That's something that you're not going to get on, I'm pretty sure, any existing VM that's out there today. Also, the AVM is multi-threaded. It supports concurrent transaction execution. As far as I know, no one else has done this in the blockchain space. I know that EOS, I think, attempted to support concurrency, but I think they attempted to do it at the actual code level, and it didn't go very well. The AVM has been supporting concurrent execution at the transaction level. So basically, you give it a batch of transactions, and it's going to greedily try and execute as many of them, depending on the number of threads it has. In terms of handling the parallelism and concurrency there, basically what we do is try and run them all. If you're detecting some hazards, detecting a rails condition, roll back everything that you just did, and then execute them sequentially. One quick fun stat that we have on that, although the AVM only formally comes out next month, we're actually currently using the AVM on the existing Aeon network for the simplest kind of transactions, which are balance transfers between two accounts. And we've noticed that it's improving the import time of large blocks by as much as 15%. So if you've got a transaction that's got a lot of transfers, using the AVM instead of the FVM to negotiate those transfers is giving us a 15% improvement in time. And that's almost entirely because of the concurrent execution. One last thing that I'll say before we switch to our live demo is, and this sort of ties back to what I was saying about encouraging innovation, I think one of the big philosophies that has gone into designing every big piece of the AVM is basically if people don't like something that we do, we want people to be able to fix it. If people think something we've done is broken or just not done in the best way possible, they should have the opportunity to fix it. And I think one of the flaws of existing systems, I'll use Ethereum as an example, and we're not criticizing Ethereum here, we're all still massive Ethereum fans, but just as an example, you can take the ABI. So anyone who's ever deployed or called a Solidity contract, you know that you've got your single ABI file that is a core part of the EVM itself. It is a core part of the language itself. And if there's something you don't like about it, tough. That's the ABI for that contract. The AVM doesn't have an ABI, actually. We provide an encoding and decoding, but that sits in userlib. So you have a default thing that you start with, and that's what we expect people to start with when they first start using the AVM. But if going down, you either think we're all idiots and built something really bad, or perhaps what we'd hope for is you realize that what we've built isn't ideally suited or has some restrictions that you don't have. For instance, you want to encode a user-defined class. You want to encode something that you've just created. You can go ahead and do that. And that's just an example of a philosophy that I think applies to many of the pieces of the AVM, where if you are dissatisfied with something, we want to push that innovation out there into the world so people can improve on what we've built, basically. And we can talk about that some more at the end when we're chatting a bit, if people have questions about other examples or how that process can kind of work. But for now, I'll stop talking, and let's actually switch to our live demo and see how you can write one of these contracts, deploy them, test them, debug them, call them, using all of our cool tools and features.
That's me.
John Matthews, everyone.
Cool. Thanks, man. Yeah, so we're just going to be running through a pretty simple demo here just to show how easy it is to spin up and actually make a contract and an application really fast using one of the plugins that our community developers made, using IntelliJ. So I'm assuming that most of you have heard of IntelliJ before. It's a pretty good IDE. It's pretty popular. I think it's the most popular Java IDE out there. So if you just give me 2 seconds, I'm just going to get this set up real quickly.
So I have a
Good.
next question.
Yep.
So the Aeon network will be its own like fork of Ethereum? Or?
The Aion network forked from Ethereum a while ago, but we've diverged from them since.
Okay, so
Yeah.
you've got your own mainnet.
Yes, yes.
Can you talk about how many nodes you expect on that?
I'm not sure how many nodes we have on it right now, but we are over a year old. We've mined over 2 million blocks on our main network right now. I don't have information about our actual activity, but that information is on our dashboard, which is easily accessible.
Sorry, I'm just playing around with the Wi-Fi here. Tell some jokes.
I don't know any jokes.
So filling in.
Yep.
So in terms of performance and scalability,
Mhm.
so it's better than Ethereum in terms of transaction throughput?
I see why you'd ask that question, given what you do. We don't have numbers on that yet, because we don't have a lot of, the AVM specifically hasn't been used a lot yet, because it's just getting out there. So we don't have numbers on it, but at the very least, we're suspecting that the multi-threaded execution is gonna improve throughput. It is proof of work, but if you stick around, we're actually moving to a hybrid consensus protocol, and I'll be mentioning that at the end of the talk. But right now, it is a pure proof of work network.
It's the
yeah.
super secret surprise that I'm keeping until the end.
The plot twist.
Cool. So I've sorted myself out now. So I'm just going to run over. So we've got a plugin for IntelliJ called Aeon 4J. It's available on the IntelliJ marketplace. So if you go into configure plugins, you can just search for Aeon in here. And you'll get this Aeon AVM integration. So what this does is essentially running a very sort of localized node on your machine, but it only runs at execution time. So it's not like constantly, it's not super heavy loading or anything like that. You can run it on a MacBook that we all know has no processing power whatsoever. So yeah, that's pretty much just how you install it. You can also get like the bleeding edge versions if you wanted from GitHub. We've got guides on how to do that, but this is just how you get the standard stuff. And that's the end of the presentation, apparently. Cool, okay. So I'm just going to run through creating a super simple hello world or hello AVM project. So you start by clicking on create new project. And then from the left side here, you select Maven, and then we've got these archetypes. For people who aren't really aware, archetypes are kind of like a boilerplate template for your project. So you can have different archetypes, like we've got loads here, and they're for very specific project use cases. So there's one for like making an Android application, there's ones for using the AVM and things like that. So I'm just going to go here and select the latest version for the AVM archetype. And then if you've done Java development before, group ID and artifact ID are like, in the Java community, they're very picky about what you choose for names. You don't really need to put anything super exciting here, so I'm just going to put Aeon and then just example. But if you're creating like a larger project, there's a whole sort of ream of documentation that Apache have put out because they create this whole section telling you how that works. But yeah, so you just click next, and so it's going to throw in an example, which is fine. And so the Aeon 4J plugin and Maven themselves actually work hand in hand. Have I done something wrong? Oh. So they create the whole project for you, which is really cool. So is something wrong? Oh, cool. Yeah. It's not that. It's the. Yeah, no, it's not that hand. Yeah, I need the HTML, the USB-C one.
Thank you.
Isn't Apple great making everyone need dongles? Has anyone got a MacBook in here? Isn't it really aggravating? You now have to have dongles for it. It's incredibly annoying. Anyway, the rest of the presentation is going to be about how Apple ruining dongle. In fact, they're kind of creating an industry.
Please focus.
Sorry. Okay, cool. So it's kind of we've made our project here. So we've got this example project, and what you get for free are 2 files. So you get a main class, which is all the way down here. So this is our contract, and then you also get like a test case, which is incredible, straight off the bat, which just allows you to run through testing within IntelliJ. As far as I know, there isn't anything straight off the bat for Ethereum developers. You have to download extra plugins and things like that. So just having this all contained in like one IDE just speeds up the whole process of actually doing test-driven development. I really like it. But yeah, okay, so we've got these classes, right? But what we need to do first is to initialize the project. And where is... It's not showing up. Sorry. Here we go. Run initialize. So that creates this lib folder, which is where the AVM jar actually sits. So this is what's processing all our transactions and our methods and things like that. So now we've got that, we can just take a quick look at this, what the contract we've got here. Now this is something Aayush alluded to before. We've got this ABI section. So every function that is going to be publicly accessible for users is going to have this callable annotation on the top. If you don't have something like that, so say you had this, then you could turn this into like a private function. This is only callable within this contract. It's not callable for anyone outside of the contract. It's not callable from another contract. It's just going to remain inside this thing. But let's put that back. Cool. So let's say we just wrote this contract. It's pretty simple. There's a get string method, there's a set string method, and there's these 2 things here that just print out hello AVM or hello, then put in a name. So we're just going to deploy it locally first. So you get this section down here, the Aeon virtual machine. This comes with the plugin. And then that splits off into 2 sections here. So you got like an embedded section and a remote section. Right now we're going to focus on embedded because I guess when you're making your application, you're going to be doing stuff locally and testing it all out locally just to speed things up. So let's click up here to select the project that we need. Go down here. And then, oops, sorry. Oops, I'll do. Sorry, give me 2 seconds. I was running a later build of the plugin on here, so I've not done a huge amount of testing on it. Aayush, tell some more jokes.
I don't know any jokes. I never have and never will. I can do the toadstool joke, but I don't want to.
Yeah, tell that one.
No, it's not good.
Okay, this is strange. Give me 2 seconds, sorry.
I guess I will tell the toadstool joke. Do you have a question? That's probably a better use of our time.
So any plans in terms of bridging to other systems as opposed to that?
That's something we've talked about a lot at Aion. It was sort of one of our foundational principles. I'm not sure where we're at right now. Right now, we just want to put the AVM out there and try and get people. Probably the biggest goal with the AVM is try to get people who had never written a smart contract before and probably felt too intimidated about the idea of writing a smart contract to be like, hey, it's easy. It's just like any other program. But that's certainly still a possibility.
I think, sorry, I have to just reinitialize.
Okay.
This built on top of JVM, right? Any plans for building on .NET framework? Those are like very...
Not right now, no. Yeah. I think the next sort of extension thing that we'd like to do is to support other languages that are built on top of the JVM, because that's sort of an easier, low-hanging fruit to achieve. So, because Scala is getting more popular day by day, so that's probably our next direction to head in. But yeah, no plans for .NET just yet. It's an interesting idea, though.
Because they are like very...
You're right, yeah.
I mean, they are also, they have, Microsoft also open source their core libraries and everything like JVM is.
Right.
C# is equally competent like Java. There are several applications running on Java. There is a code base, there is a user base, a programmer developer
No, you're definitely right. Yeah.
So yeah, I mean, it would be a good idea to have it on C#.
Agreed. It makes sense.
Sorry, 2 seconds here.
Sorry, one question that I should have asked when I was sort of polling the audience: how many people are Java developers here, or like have non-trivial Java experience? Just so we know who we're talking to. Okay, cool.
What IDE do you normally use?
Me?
Yeah.
Lately, it's been VS Code and Visual Studio.
Cool.
I've been more of a C#.
Cool.
And Solidity mostly right now.
Okay.
But Java, a couple years ago was my thing.
Here we go. Okay, cool. I'm also a VS Code user myself. And what's really cool, this plugin actually contains, you don't have to use IntelliJ if you wanted to. You can just use the Maven side of things, and I can walk through that later if you want. But then you can just use whatever IDE you want to use as long as you've got like the AVM on your machine. It works out really well. Cool. Yeah, so there was an issue with our last project in that, I'm just going to blame it on Apple again. Why not? It's the dongle situation yet again.
Up to the jar.
Yeah. Cool. So we've got the same. I've just recreated a project here. So we've got the exact same contract running here. This is, again, like the boilerplate contract that you get with all the callable functions and things like that. So if we just go up here and then deploy it locally, I'll just show you what happens. Oh, now it's not there. Here we go. Cool. So when you set up the deployment window, it's going to ask you, are there any deployment arguments you need to put into this? And I'll go into this in a second, but you can create something called a cleanet, which is, I think in the Solidity world, it's called the constructor.
Yes.
Something like that. So when you create a contract, you can set these deployment arguments. So these functions will run, but they'll only run on the time that you deploy the contract. But we've not got any of those here, so we're just going to click OK. It's going to run through. Cool. So we just deployed this contract locally to the machine. It took a little bit longer because it always does the first time you run it. When you initialize the project, you get this whole the AVM jar section here. So it just takes a little bit longer the first time. But now we've got this contract running on our machine, so we can now call these functions. So let's get this string. So you just right-click on what you want to call, go down to the Aeon virtual machine, embedded, click on call. And then again, if there's any arguments, it's going to ask you for them. If there's not, you can just click OK. And cool. So it's just called that, and then this is the response that we get. So this is the data that is returned, and then there's also this section here. This is mainly just for debugging on local contracts. So this current string is hello AVM. That's being returned by this line here, blockchain print line, current string is my string. So we've got that, that's cool. So let's try and change this variable up here, then this my string. So let's go down to this set string method, do the exact same stuff, right click, click here. And also if you notice on the side here, there's these keyboard shortcuts, which just speeds things up, but I'm just going to click just so that you guys are aware of what I'm doing. So click in here, let's set a new string. What should the new string be?
Test drive.
Test drive. The last hackathon presentation I did, everyone was just shouting Brexit jokes at me. So when I did this, they're like, Theresa May, Brexit. And I was like, all right, yeah, thanks, guys. Cool. So that's built again. You can see down here, build success. And here we go. So the new string is test drive. So we're just going to call this getString method again. Down here. Again, no arguments. And cool. OK, so we've changed that one string of data. Obviously, it's not super exciting, but I'm just trying to get across the fact that it's incredibly easy and fast to do this. Like, I've not done any programming yet. I've not changed anything. This is just what you get straight off the bat. So let's just run a bit forward in the future here. So let's just say that we've made this really cool contract. We've got this great DApp, and we just want to deploy that to like a testnet now. So as I was saying before, there is a section within this IDE to just do that. So this remote section here. So you get all the same calls. Well, you get the same calls and then some ones on top. So you get deploy, call, contract transaction, get balance, and things like that. So we're just going to run through that because I think we've got a decent chunk of time here. So before we can do that, we're going to head over to the configuration section. So here we're going to be putting in the Aeon node that we're going to be talking to, and then also the private key of the account that's going to be doing the deploying and calling, because obviously it's on the testnet, so it is going to, we're going to need to use some fake internet money, essentially. So first off, we're going to grab a node. We're actually going to be using Nodesmith. I believe Brendan from Nodesmith is here. Hey, man. Nodesmith, it's essentially just a node hosting platform where you can use their nodes for free. It's really handy, and it's really easy to do. So just log into this, make this a bit bigger, and then it'll crash.
Blame Nodesmith this time.
Yeah, this is Nodesmith are colluding with Apple.
Nexus of corruption.
So I'm just going to grab this. Like I said before, Nodesmith completely free. So if you guys want to, play along, just go to nodesmith.io. Just log in. You can log in with GitHub, and that's that. So let's grab this, paste it in here, and then we need our private key. This is where I'm going to try and have faith here and assume that none of you are going to steal my private key for the very short time that it's going to be on the screen. Desktop notes. Cool. Okay, so that was all the setup you really need to do. You just need your AVM endpoint and then your private key. And then it also makes sense to have tokens in that private key, which I already have. You can get them. We've got several faucets available, testnet faucets, so you can just use that. So let's go to here, and then what we need to do, what was I going to do next? Yeah, okay, cool. So we're going to deploy this contract to the testnet. Let's grab here. And just like before, it's going to ask me for any deployment arguments, so we don't have any right now, so we're just going to click OK once the screen lets me do what I want. Cool. So obviously this is running on an actual network, so the transactions need to get mined. That's what happens in a blockchain. So that's what's happening right now. So we've deployed the contract, and then we're just waiting for the transaction to get mined. This happens automatically, so you just have to wait for these timeouts. And there's a huge bunch of useful information here now as well. So you get the parameter data set that's going in, stuff like that. You get the sender address if you needed to copy that down, stuff like that. Oh, here we go.
Sorry, just one quick thing that I'll say is the Aeon network has a block time of about 10 seconds, so it's reasonable to just wait for it to show up.
Yeah. Cool. So that's just been deployed now. So now we can call this contract on the AVM testnet, just like we did before. So let's call getString again. Down to remote and call. And here we go. You'll notice what actually happens here. Because we're running on a remote node, you don't see the output of this blockchain.println. That's because that gets printed out directly to the terminal it's working on. But because we don't have access to that terminal, we're just getting the response from the blockchain. You don't see this current string is my string. So there's that. So cool. So we've got that. So let's just try and set the string now. To do this is a slightly different transaction. So it's a contract transaction because we're changing the state of the blockchain. It's not just a call. When you're running on the embedded AVM, you don't have to specify that because it just automatically knows what you want to do. So again, let's set it to test drive with a point on the end.
The creativity is that limited.
I know.
You just couldn't think of a second string.
Yeah. Cool. So here we go. So we get this transaction receipt, which is kind of cool in the way that on the embedded AVM, it's automatically going to just respond with what you put in. Okay, cool. So now we've just done this contract transaction, so we're just going to pull it again. So we can go here. And we can either put in the receipt itself, or we can just click recent, and it's just the AVM, the plugin itself does a lot of caching and remembers the contracts that you used and the addresses and stuff like that. And oh, it didn't grab it. Okay. Oh right, I see. So we set the string. I forgot I was doing the wrong thing. So we need to now get the string. So we go here. remote call, done. And cool. Okay. So we've just deployed locally, that took 2 minutes. Then we've deployed on a remote node, so that took another 2 minutes. So it's just kind of, I'm trying to showcase here how fast and easy it is to do this kind of stuff. As I mentioned before, there are keyboard shortcuts, which is when I'm developing contracts myself, I will be pressing those, just speeds things up. And it's just incredible that you don't ever have to leave this IDE to get anything, to do anything, if that makes sense. So one last thing I wanted to point out, I mentioned it before, there's this thing called the cleanet or the clinet. I'm not sure how you pronounce it. Cleanet. Java term. Yeah, we didn't make it. And that is a way to sort of deploy or create deployment arguments on the contract as it deploys. So we can do something like this. So it's a static thing. Put this in here, and we can set my string to Brexit. You know, let's just take this up here. Yeah, what's going on? Oh, I see. Let's cut this out here. Cool, so all that's going to happen is when we deploy this, I'll just deploy it locally to here, embedded. Oh, you need to be over here, sorry. Deployment arguments, we don't have any. It's just going to be set into Brexit. Cool. And then we can just call getString. And cool, so that's just setting that. And obviously, like, this example is incredibly simple. I've tried to keep it as simple as possible, just to kind of showcase how fast this is and how easy it is to get things up and running. So, I mean, that's about as much as I want to go through right here, right now.
Sure. One thing that I'll say real quick, just in this case, we just hard-coded the deployment argument, but every time you see that deployment argument option of stuff that you can pass in, so that would actually be passed into your static initializer, which is what we call those blocks in Java. And you can pull those values out using the AVM's API. So there's a blockchain.getData option, and that'll give you whatever deployment arguments you sent to the AVM.
Cool.
But yeah, anyway, thank you for that. So basically, if it wasn't obvious, the rough point that we're trying to make here is that process is a lot easier than it is when you do similar things on Solidity. It's certainly easier than when I've attempted to write Solidity contracts, which never goes well. Debugging is easier, testing locally is easier on a standalone blockchain that's just living on your local, and also deploying to a testnet is fairly easy as well. And that's really what we're hoping people will be primarily excited about. There are good arguments that we have made. There's some documentation and articles that we've written about why people that are already well versed in the Solidity, Ethereum, just existing blockchain space should be excited about the AVM and the benefits that it has. But in many ways, I think the true strength lies in people that have never written a smart contract before and are intimidated by having to go through Salty and Truffle and whatever else the environment might require. We're hoping that this will be a lot less intimidating, like I said. All right, so that's basically all the prepared stuff that we have. There's a lot more stuff that we can talk about, but if we have any questions, we can take them now, or we can jump into more technical stuff.
I got a question.
Mm-hmm.
So, can you go over, like, is it easy to interact with the smart contracts through Java once you kind of have them defined and stuff? Like,
Yeah.
if I wanted to, like, run code that could work on top of the smart contracts that I've written?
Do you want smart contracts talking to each other, or do you just want something local that's talking to your smart contract? I can answer both.
Answer both then.
Sure. So two Java-based smart contracts that talk to each other is fairly simple. The APIs that the AVM exposes, so that, again, that blockchain class that you see there sort of exposes most of the APIs that contracts can access. In there are APIs exposed to deploy new contracts from within a contract, to call existing contracts, to send money to a contract, and so on and so forth. So basically, you have the full suite of options there. For the local question, that's a bit of a different question because it comes down to how you're interacting with the Aion network itself. Right now, the Aion network has two sort of inbuilt APIs. We do have a Java API, but we're really focused on our Web3 APIs some more. In addition to that, we have a whole suite of APIs that are built by partners, external companies, and that kind of thing. So ethers.js, which I think is the most widely used Ethereum API, has created a version for Aion and for the AVM as well. We're working with the Web3j people who built a Java API to interact with the Ethereum blockchain, and they're going to be having stuff for the AVM as well. So yeah, if you're outside the blockchain space entirely, that question comes down to how are you interacting with the network itself. And yeah, there are a few different APIs, including Java-based ones. So you could definitely write a Java program that's constantly polling the network to talk to your smart contracts.
Cool.
Cool.
Did you have more stuff you wanted to talk about?
Yeah, so what would people like to talk about on? So we can go into the technical working of the AVM some more. Actually, if you go back to the presentation, there's this one picture that I think might sort of clear up what's happening behind the scenes a bit, and I think it's valuable to look at.
Oh, I'm going to have to get your presentation back up.
Where did it go?
It just closed.
But the other thing that I did want to talk about is Unity, however. Have a slide that we can pull up later. But yeah, so this has nothing to do with the AVM itself, but Unity is the consensus protocol, the hybrid consensus protocol that we're launching and hoping to be implementing by the end of the year. It is a hybrid proof of work, proof of stake consensus protocol. Our white paper is currently out. It's been out for a couple of weeks now. It's still sort of an early draft of it. We're going to be making changes to it, filling in sections. But right now, the number one thing we want is feedback. We want people to look at it, and if they think it's very foolish, to tell us that it's very foolish. So if that's the kind of thing you're interested in, please look at our Unity white paper, because that's exciting.
Oh, here we go.
Yeah, so I think this picture does a good job of explaining exactly what the AVM does. Again, the important part that I mentioned at the start of our presentation is that the standard JVM is down here, and we have not touched that in any way. And that's what's fundamentally going to be executing all of your actual bytecode. The real AVM that you can think of is this box over here. So the users write their contracts exactly the way they normally do, using the JCL, which is the standard Java class libraries, and some of the APIs that we expose for blockchain-related functionality. When you deploy your contract, the first thing that it's going to hit is this AVM transformer. We use ASM, if people here are familiar with that technology. It's basically, it's a suite of libraries that's really good for reading and modifying Java bytecode. So the AVM transformer is going to modify whatever bytecode you've been given, as well as validate some of the assumptions, because we have restricted the scope of the JCL in many ways. Quick example of that is that multi-dimensional arrays in the JCL have no practical restriction. I think the real restriction is like 255 by 255 and so on. In AVM code, you can only have up to 3 dimensions. So that's an example of the kind of transformations and validation that the AVM transformer is going to do. It also maps all of your references to the JCL in what we call the shadow JCL. The shadow JCL is basically an AVM rewrite of the JCL. So I don't want to talk about Java too much if people here aren't super familiar with it, but basically all of the standard Java operations exist in the JCL. In the shadow JCL version, they're slightly modified mostly to ensure determinism, because that's one of the core requirements that any blockchain virtual machine needs to have. It's also modified to add support for things like billing. Every operation that you make is billed, and we've got like a very detailed fee schedule that people can look at. We don't yet have numbers on the comparison of Solidity costs versus Java costs, but the goal building the AVM was that those costs should be comparable. And then once that transformer is done, this is what actually gets deployed and run on the AVM, which is really just running directly on the JVM. Any operation will involve billing that happens from runtime support, and can talk to other contracts or talk back to the user, logging. We have a concept of events like Solidity does, all of which comes from our APIs. So that's sort of the big picture of what the AVM is. Okay, the next slide, we can leave this one on, but this is our little blurb about Unity. But I'll reiterate that people should read the white paper if they are interested. All right, any other questions? Anything that people want to talk about at all? AVM related, Aeon in general?
Brexit related. Everyone's favorite topic. Apple related.
That's your favorite topic and no all right. In that case, we'll leave it at that. If you have other feedback, anything, if you'd like to reach out to us, we'll both be here for the rest of the day. Our contact info is on here. Yeah, if you really anything that any information or criticism that you have regarding to the AVM or Aion in general, we're very interested in hearing it. And I hope we convinced people that that writing contracts will be easier using Java on the AVM. And that's the point we're trying to make. The world's first Java-based virtual machine that sits on a blockchain. Woo!
Cool. Ooh.